So today I'll be focusing on kind of an intro to protocol studies, intro to protocol thinking. We'll do some case studies, overview some key terms, and kind of look at where the field's going. So with that, here are the slides. And I've called this argument engineering for dummies like me who need a little bit of an overview with some terms to get up to speed on this stuff quickly. We have a lot of written content, but it's nice to have video as well. Bit of an outline. So, as I said, this talk is adapted from our workshop program. I'll do an intro. Who am I? Where's the program? We'll talk about accelerating order, engineered arguments. What is the definition of a protocol? How do you study them? How do you talk about them? How do you use these things in real life? And where's the field going? So, a bit of an intro about me. So, I kind of came into this protocol studies thing in an interesting way. I was working at a quantum computing startup fresh out of college. That was really fun. At the time, I was an avid reader of Ribbon Farm. Um, After one qubit, I put I decided that it was an interesting problem, but not so much for me. And my old contacts at the BC government were like, "Hey, do you want to come work on this quantum computing institution that we're putting together to do research?" That sounded interesting. Did that for about 8 months. COVID hit. Went to Yukon government, which is where I grew up, and then SOP announced this program. I applied, and now I'm helping coordinate the program. So this has been quite the journey so far, and I'm excited to share with you what I've learned. Why did Summer of Protocols start? It's funded by the Ethereum Foundation, and the specific problem that the EF was interested in was the resilience of the blockchain, which is, as I understand it, a very difficult problem. And they had this idea. Tim Bako contacted Venkatesh Rao, and they decided, well, maybe if we studied protocols more broadly, we would understand the specific problem better and find some new patterns to generate solutions for blockchain in particular. We're going into the third year of SOP now. It started in 2022 with a pilot study. In 2023, this was kind of the research-focused part of the program. 35 researchers came together to do theory, and then we switched gears into real-world protocol improvement, which was team-based. We had people working in the field go out and experiment with things from preventative burns to flood management to encryption to augmented reality and negotiating those realities together. That was really cool. And we've decided earlier this year to come together and take those learnings from the past 2 years and move into teaching. So, what did we learn in theory? What did we learn in practice? Let's get some excellent teachers together, turn this stuff into open source curriculums, and put it out there. We were also running a science fiction magazine, which I'll talk about. We're also running workshops, which I'll talk about. And holy smokes, has it been a lot of work, but it's very exciting. Here's some of the things that we've built in the last few years. There's the protocol kit, which was from first summer, Protocolize, which has gone through a pretty significant rebrand and is now focused on protocol fiction, kind of exploring strange new rules, not special people. I'll get more into that towards the end of the presentation. YouTube channel, which you're probably watching now. There's a Discord, which I highly encourage you to join. There's a link in the comments in the chat. And an excerpt from the protocol reader, which if you want to get really up to speed on this stuff in the course of a weekend, I would recommend going to the summerofprotocols.com website, downloading the EPUB of the protocol reader, and just getting into it. We're pretty confident that you can get up to speed in the course of a weekend. This is a very young field, and that stuff is potent. So you're able to do it. Couple images from the past few years. We've had conferences in Seattle, Singapore, Healdsburg, Chiang Mai, and of course, we love when people share photos of their protocol kit, and this one happened to be mostly focused on the cat that was in the image, who looks like he knows what he's talking about. So now it's time for everybody's favorite question. What is a protocol? This was a big topic of debate in the first summer. what is a protocol? And everybody wanted to come to a definition very quickly. And this was recommended against us doing that. I was a researcher in the first cohort, and Venkat and Tim said, don't worry about definitions too much. We're going to go ahead and just like study this stuff, come up with your own definition if you want, and we'll come to a better definition later. So here you've got the Merriam-Webster like classic definitions of a couple different contexts, which hasn't been updated to fully reflect the reality of today with like Ethereum protocols, blockchain protocols, like the huge extent of things from everything from workplace safety to encryption. So Danny Ryan from the Ethereum Foundation came up with this more complicated one in 2022. A protocol is a stratum of codified behavior that allows for the construction or emergence of complex coordinated behaviors at adjacent loci. We'll dig into what those words mean later, but this eventually boiled down to a much more succinct definition of protocol, which was a protocol is an engineered argument. There are different groups that have disagreements. They need to come to an agreement about how to behave, but it's a constant give and take. So you're not really getting everybody to do exactly the same thing or agree on things in principle to a very fine detail. You're putting a pause on the argument, engineering it in some way so that everybody can move on and do something more interesting together at a different place or time. That said, definitions are good, but we shouldn't ruin a useful idea with a lifeless schema. That's Rene Lévi-Strauss, his idea of a lifeless schema. I think that a protocol, you know it when you see it, and you shouldn't worry too much about what is and isn't a protocol. As we'll see later, like you don't need to know exactly. You can get a lot out of this stuff without digging into the weeds of etymology and terms and grammar. But if you are a definition buff and want to put forth a challenger, go ahead and read the intro to the protocol reader and then come up with a new definition. We're pretty sure that we'll convince you of engineered argument in that essay. So, how do you study protocols? Now that we know what a protocol is and what this program is about. There are a couple of different methods to studying protocols, both of which we highly encourage. There are the more STEM side of things, programming, programmable cryptography, ops research, randomized control trials, like practice through engineering and technical things. But you've also got the more anthropological side where you can go out and like look how people work. You can study history, you can do art, and you can think about it in philosophical terms. Both of these things are valuable for understanding protocols because fundamentally they span a range from like highly technical to highly social. So you've got things like how people use MRI machines or X-ray machines, which are super, super complicated and can be quite dangerous. So you need to follow these technical protocols that are very much based on science in order to use those machines. Or internet protocols, which are technical standards for how machines talk to each other. On the other hand, you've got protocols like talking sticks or how different groups negotiate at a table or how you're supposed to set the table at a conference, which are not technical. Like these things are very vibe based and better studied through art and anthropological methods. And we like to integrate both because that gives you a full picture of the power of a protocol and their importance in the world. And this ties back to the really, really big picture here, which is kind of what Pope Leo, the recent Pope, chose his name in part because he was saying like the big task for his role as Pope now is to help people navigate this kind of like, I guess, fourth or fifth industrial revolution, whichever number we're on, about the impact of AI on the world. And this happened in the Industrial Revolution. We've had so much technological advance between smartphones and computers and medicine, different types of advanced machinery. And we have this kind of like protocolization debt that's overhanging and we need to deal with. But more technologies are coming down the pipe. So on the one hand, protocols is going to like help us relieve that protocolization debt, which I'll talk about later. And it's also going to potentially help us predict how social responses to new technologies might unfold. You can learn more about that from a Field Builders podcast episode we recorded a couple days ago with David Lang, who's also an alumni of the program. So let's get into it. Now that we know what they are, how you study them, how do you think about protocols and use this stuff? And I think a great place to start is with this idea of literacy. And one of the important parts of literacy is vocabulary. So, at risk of going down the rabbit hole and picking some words that just sound good, but don't mean much, I'm going to go ahead and share a few that I think are pretty impactful. And these words, again, you don't need to get too strict on definitions here, but they're great places to start thinking about the world in a slightly different way. Through a slightly different lens that might help you approach problems differently. Start managing problems that you should be managing and not solving. And this is a very important theme. So here are some. And you saw from Danny Ryan's definition earlier that there's some kind of complicated terminology. For me, like coming into this field as a layperson, I didn't know what a loci was. I didn't know what strata meant. I didn't know what an agent was in like that particular sense. We talked about what an engineered argument is, but these other words, agents, strata, loci, tensions, Whitehead advance, Kafka protocols, what are these things? They're very useful once you know what they are. But I will say, as I'm walking us through these words, keep in mind that vocabulary is only a small part of literacy. These terms need to work together in a way that yields a greater whole than the sum of its parts. If you're just plugging cool words into your speech, but they don't mean anything, it's going to be like a game. You're going to sound cool. People might think you're smart, but at the end of the day, you're going to think about the world in the same way. So definitely try and think about these words as like, oh, these are concepts in my mental toolkit that I can use and apply to new situations to give myself a different perspective that would lend itself to a better solution or management strategy for problems that don't go away. So, to start us off, strata and loci. These were two terms in that kind of complex definition. And they're, in a sense, kind of geological. So you can think of strata like sedimentary layers in a rock surface. So they're connected to each other, like they're stacked, but they're also connected laterally. One layer of behavior in kind of a broader area. So if you look at a team in a workplace, there are strata of behavior that people have with regards to meetings, with regards to how they get work done, how they communicate. These can be contained or bridged to another local area, which we call loci. Singular of that is locus. A locus is a loosely bounded area which contains a mixture of agents, technology, and content which interact, and they sometimes conflict. And a loci can be either two different physical places or the same physical place at a different place in time. Attention is kind of an upgrade from the concept of a trade-off. A trade-off is a strict engineering idea, and a conflict is a social science idea. So every loci has a set of trade-offs that determines how those actors or agents behave. Each agent has a different preference with regard to the underlying trade-offs in their loci. These differing preferences generate conflict, and those conflicts and tensions are what protocols seek to manage. These tensions could be things as simple as productivity versus safety to something as niche and complicated as structured versus chaotic storage. So, protocolization. Protocolization is the process of a loci or multiple loci, a locus or multiple loci becoming embedded with protocols. So you have technological advance and then you have protocols which kind of come in as the wrapper for a technology that bring it up to speed with the preferences of the actors in that space. Protocols can make things safer, they can make things more effective, they can help us use technologies without thinking about them, which is kind of one of the fundamental ideas that's come out of this program is this idea of Whitehead advance. Alfred North Whitehead was a philosopher and logician who had this very great quote: "Civilization advances by extending the number of important operations which we can perform without thinking of them." When we create new technologies, it's kind of a chaotic force. They emerge somehow, they get created, they proliferate in the world. They can be unintuitive, even dangerous, and to use them effectively, it's a matter of skills, but also like, how do we talk about this technology? How do we communicate better ways to use it? And eventually, how can we start to use this technology without even thinking about it? If you drop somebody from 1800 in today's environment, they wouldn't know what a crosswalk was. We don't even think about it, but there are pieces of like 3,000 to 10,000 chunks of metal hurtling down concrete like 4 feet away from each other. And you could just do something as simple as looking both ways before you cross the road, which is a protocol, and get across safely. And we barely even think about it. We're taught this at a young age. It's a kind of literacy about the technological environment that is necessary to create Whitehead Advance, which is kind of the gold standard of protocolization. On the other end of protocolization, you have what we like to call the Kafka index. And this was like a really fun piece of research that came out of the early days of SOP. People were thinking about, how do we know what a good protocol is? Somebody said, well, a good protocol is not a bad protocol, and you have to know what a bad protocol is. So the Kafka index was a measure of protocol badness. In a Kafka protocol, it's like the TSA, or trying to get something approved by the public utility district, which I've been trying to do lately. It's a nightmare. There's no feedback loop. You put something out there, you don't get anything back. Everybody goes through the same process, so it's massive and time consuming. You actually have to make more decisions than you would if you just had to do it on your own. Um, and there are defection costs. If you don't do what the TSA says, you're going to be in a lot of trouble, especially today. If you don't do what the PUD says, you're going to be, I don't know, that's going to be real nasty. These are prone to agent error as well. So you're going through these processes, and it's not always obvious what you should do. There are consequences for error, and it's really easy to make a mistake in these contexts. There's a lack of consistency. You don't know when you're doing the right thing. You kind of have to guess. You have to see what other people are doing. And even when you make mistakes, or if you don't make mistakes, your success isn't guaranteed in the Kafka protocol. Those terms of success are random or ambiguous. And kind of the most terrifying idea of the Kafka protocol, the bottom of the Kafka index, is getting stuck in a whirlpool where you are permanently stuck in the TSA. You say, I can't find my way around in this darkness, and you are in the middle of a Kafka book. And then the third kind of element of protocolization, which is useful to think about, is protocolization debt. So this is a quote from issue 1 of the new version of Protocolized. We have fallen way behind on the task of creating new kinds of order out of all this rich, wild technological phenomenology. We live in a technological tangled bank, which is a combination of social elements and technological elements, and we keep introducing new technologies which have these like huge suites of optionality and risks and hazards and opportunities that produce, and those need to be steered in a way that we get the most out of them. It's not like you can just create like a microwave and put it out there and right away people will do the right thing. The affordances of a technology, what it kind of encourages you to do when you see it, aren't optimal. You need to have literacy to tell you the right thing to do with the technology to get the most out of it. In a sense, for every new technology, humans are the second settings panel. This progress is great, but on its own, it's just chaotic. You do need to have some changes in human behavior to make sure that technological progress turns into the gold standard of Whitehead Advance and not just a force that generates Kafka protocols everywhere. Another concept, and this is one of the ones with tension that we'll dive into deeper in this sort of mini lecture is a Hardened Commons. And this is a combination of two concepts that emerged from people that work at the EF, Josh Stark and Trent Van Epps. Josh Stark came up with this idea of hardness, and Trent Van Epps went really deep on the concept of a commons in software. And you can get both of those essays here. I have linked to the slide deck in the description of this video, so that's got a ton of resources. Highly recommend you go check it out. A hardened commons is a system that produces or stores shared resources made exceptionally resilient to classical vulnerabilities through technological means. Commons face a ton of issues. You can think about a park that has been abused by mining companies, campers, people poaching, people dumping waste into the rivers. You have commons like economic markets where people manipulate cars to make them seem better, and people sell them at a high price and get ripped off because there are no protections for consumers. You can get into situations in legal systems where a small minority of 5% is able to exert more influence on the system than they should because of the structure. So if you have a three-party system, a swing vote of 5% could shift the entire outcome of an election from a winning to a losing one, but it's just 5% of the population. Yet they have roughly, a third of the power, if not more, in that scenario. And then there's classic tragedy of the commons. How do you maintain a commons if nobody wants to do it and it's costly? Eventually, these things decline and things go bad. So, hardened commons is something like a national park that's been able to use certain protocols and technologies to keep everything in line. They're able to use bear cans to keep bears away from campers, to avoid those bears from becoming problem bears. They have park officers, which help enforce standards of littering and so on to keep that park clean. You have funding mechanisms for parks, either through donations or through tax systems, voting mechanisms to decide the development of that park. All of these combinations of technology and protocols are used to harden a commons that is typically vulnerable to these things listed here. Okay, so now we have a few tools, we have a few ideas, we have some basic vocabulary, and now it's time to start applying this vocabulary in a way that builds literacy. That means going out in the real world, looking at protocols and seeing, okay, now that I have these concepts, how can I use them in a way that takes me to a different perspective, a more thorough solution or a more efficient solution to the problem that I'm facing? Or in many cases, am I facing a problem that shouldn't be solved and I should just focus on managing the tension, the conflict arising from different preferences for a trade off between the agents in this system? This is a case study from last year by Jordi Rosales and Natalia Scherer, who wrote an interesting essay on this as well and protocolized, I think around issue 5. You can also watch their presentation linked in the slides. They set out in Sonoma County to improve the protocols for getting prescribed burns approved in the state of California. The state of California has a quota that they're supposed to meet each year to do preventative burning of forests in order to prevent huge out of control wildfires. It's very difficult to get these approvals done because there are so many stakeholders with conflicting interests, and they were able to use the concept of attention, which is these actors or agents in different loci who are connected by a behavioral strata, and they have different preferences with regards to trade-offs like breathability of their air versus the frequency of wildfires, security versus upfront costs, privacy versus freedom, issues of aesthetics versus issues of safety. Plot these out to help all those stakeholders come up with more efficient protocols for approval that would allow Sonoma County, and more broadly, if it was adopted, the state of California to meet prescribed burn protocols, prescribed burn quotas. everybody wants to do it, but there's this tragedy of the commons that happens with forests that needs to be hardened against through protocols and technology. And this was a very interesting case study that these guys did because they actually went in and they mapped out the entire approval process, which is like the most Kafka-esque thing I've seen. And I've seen documentation of the TSA and other government approval processes. And this particular one was like, it was enormous. And they went in and they found good places to intervene, good places to set up protocols that would temporarily settle the differences or arguments between agents, engineer some hardness into the system to encourage future action. The other case study that I'd like to mention, also from last summer, was by Celeste Lecomte and Daniel Butler, and they were looking in urban settings at flooding. So sea level rise is not this steady process. It kind of brings up the level of water, but also increases the regularity, frequency, and the magnitude at which flooding events can occur. And what they found was that our protocols to deal with flooding are rooted in our perceptions of water as a hazard. And then they went on to look at classification protocols for water in urban spaces. And they did some very interesting hacking in the true spirit of a protocol punk. And they said, okay, we've got these bodies of water here, which are treated as hazards, and they're super ugly. But we looked up and we know that if these waters are used for public purposes, that cities have to maintain a higher level of cleanliness in those waterways. So they went out and they started hosting parties on boats in the middle of these like grimy, gross, like New York city waterways. And because they were doing that and hacking these protocols, the city had to go in, clean the waters up, turn it into an actual useful piece of a useful resource for the city, rather than viewing water as strictly a risk and a hazard to be kept out. So these protocols on how we classify things are a very important part of defining how urban development happens. Danielle and Celeste went through this process of identifying different classification protocols in different cities, different adaptations to shoreline flooding all over the world, and made this catalog of them. And what they found was if you harden a commons too much, the rigidity of that commons can start to defeat itself. You need to have kind of this semi-porous relationship with the hazards you're dealing with. Otherwise, you are just suppressing it and suppressing it and suppressing it in what was a unexpected through line with fire. Because you know that like if you don't burn things, the fuel builds up and then you have explosive fires. But it doesn't have the same intuitive nature as like flooding doesn't have the same intuitive nature where if you build dams, all of a sudden you have like this increasing maintenance debt of these dams. You're keeping more and more water out because of sea level rise. And people continue to just view water in a way that's a threat instead of renegotiating their position with water and hardening their commons in a way that's not as rigid. So coming up with protocols like Danielle and Celeste have, where water is allowed to come into the city as a useful thing, people can interact with it, and this also takes the burden off of urban designers to create huge barriers because they can have porous things that people can enjoy that also provide safety in the long run. So those are a couple like case studies about how this can be applied in like both an urban and rural context in terms of natural resources and development of cities. But I'd like to talk about tensions and hardened commons a little bit as these two concepts which we found particularly useful along with the others. So over the past 2 years, I've run multiple workshops and sessions on tensions and what we call the tensions game. So I get people to think about trade-offs and conflicts as a way to upgrade their thinking about classic engineering concepts, which is this binary idea of like, well, if we do this, we do less of that. If we do that, we do less of this. It's a good way to think about things, but I think you can significantly level up by introducing the concept of conflict, adding these things together to make a tension. And that's what this workshop next week with the California Metropolitan Water District is going to be about. We're going to look at the tensions between different agents in a hybrid meeting context to come up with better protocols. And I'm really excited for that workshop. We'll publish the template for that, hopefully as well as the findings in a couple weeks. So when you apply tensions, you have to look at the trade-off that is underlying the loci. So in the context of allergen safeties, and this one's like near and dear to my heart, I usually give the example of wolves in Yellowstone, but I've found that this one's kind of fun. So there's this huge tension between the preference of public health policy and like the public in terms of their health and what nature wants to do, which is kind of a weird way to frame a tension as like nature is an agent, public health is another. But this is how it works. And each side has proponents reflected in society. So there are a lot of people that were like, well, we have this eat dirt theory. I grew up eating dirt. I'm not allergic to peanuts. These kids need to get outside and eat more dirt. I've got people in my family that promoted that as well. And then you've got the bubble babies and like the bubble kids with their helicopter parents who said, hey, we need to like not have any allergic reactions at all, keep the peanuts out of schools, zero tolerance. These were both valid arguments. These are both valid positions along that trade-off curve. The zero tolerance policy won out. It prevailed. It was written into public health policy, implemented, and then allergies went up. And everybody said, wait, okay, the policy's not working. Instead of fixing the policy, I think we should just double down, work on compliance, educate people, and that will fix the issue. And then you saw another uptick in peanut allergies. You're like, okay, maybe the medicine was worse than the cure. The zero tolerance policy was actually increasing the rate of peanut allergies, which was in the long run increasing the rate of reactions. So there had to be a protocol innovation here that navigated the tension between no one has a reaction, zero exposure versus letting nature do its work. And this is where the LEAP program, Learn Early About Peanuts, came from. It is a sort of engineered argument between public health and nature where you are gradually exposing people based on a rigorous scientific idea. You're exposing them to allergens to build up tolerance. And it's been hugely successful. Children that go through the LEAP program have like double-digit improvements in allergies. Like the probability that they will develop an allergy as an adult goes way down. And not just by like 0.5%. We're talking like 10, 15% improvements in allergy development because of a very subtle change in protocol and the application of technology like allergy testing. So immune systems have been able to like adapt generation to generation, and there's intragenerational improvements in safety because of this protocol. The second idea that I would like to show you how to put into practice is the Hardened Commons. In addition to tensions, I think they go very well together in a sense that tension is a component of Hardened Commons. So this is our second poorly engineered argument, which is grid privatization. On the one hand, you have efficiency versus thoroughness, which is a tension that I think is very important for everybody to understand. In this case, it's represented by cost efficiency, and thoroughness is your capacity to withstand shocks. On the one hand, you have the privatization of grids in Texas, which encourage companies to trim the fat, reduce their margins, or reduce their margins of safety in order to increase profit margins, reduce their time year horizons to about 10 years, 15 years tops, focus on shareholders. And this is a valid position. Again, totally makes sense if you are trying to optimize profits. On the other hand, you have old school ideas where like we're going to have a ton of grid capacity, but we can't do that with green energy. So we need to build up a ton of peaker plants that we can turn on that are run on diesel and coal in order to meet spikes in demand or shocks. And that extra capacity is going to be kind of, I guess, dirty energy because of how green energy systems provide a constant stream of energy and are difficult to turn off and on typically. So in this situation, those like that dirty energy was considered unappealing, privatization was pursued, and then the 100-year Texas ERCOT winter storm hit, knocked out power at all of Texas. It was a huge, huge disaster because privatization was pursued. You had this occasional event that created a lot of damage. On the other side, you would have had a kind of chronic production of environmental hazards, pollution, and so on. So, what is the engineered argument in this sense? The commons is the energy infrastructure in the United States, where there is a tension between people who prefer cost efficiency to people and agents who prefer shock capacity. There was a thing called automated demand response that was integrated into some energy systems, like in California, where you were able to unlock slack because of an innovation in monitoring and data collection so that you could know how much demand for energy there was. People that weren't using energy, you could shut down the energy that was being sent to their place. That electricity could be sent elsewhere. So there wasn't a fundamental change in the capacity of the grid or with which the 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 redundancies were engineered into it. It was just, okay, we have now a technology monitoring that we can use to inform a protocol that will direct energy to the appropriate places. So you both increased margins of profit and reduced the need for dirty peaker plants through this innovation that was a combination of technology and protocol. And in the process, you hardened the commons against two failure modes, one of which was the continual production of pollution, and the other one is the risk of those 100-year storms that a 15-year time horizon organization just cannot take into account. Two birds, one protocol stone. So with that, let's kind of give you a sense of this vocabulary, what you need to do to build literacy, use these things to think about the world in a slightly different way. And I'd like to talk briefly about future directions. So there is a lot of stuff coming out from the testbed over the last couple of years. To name a few themes: anti-memetics, memory, addressable space, safety, protocol fiction, tensions, and technical foundations. I think that if you wanted to like jump in and like run with something or like contribute to a kind of emerging theme in protocol studies, getting into one of these is a good bet. There's a lot of ways that you can take protocols and run with it, but if you want to have people to like jam with and work with and like start to build out kind of a sub area of analysis and practice, these are good bets. So Nadia Asparova just published a new book on anti-memetics, which is very good. We have an interview with her from a couple weeks ago. Kia Kreutler is working on memory. She's launched a new consultancy. Protocols and memory are very interconnected. She also has an essay from the first summer that explores this, and Nadia and Natalia and Jordy's project from last year also touches on memory a lot. Janelle Hart, who's an architect, has talked about how digital protocols for organization are now driving the development of physical space rather than the other way around. I actually have a blog where I talk about safety. Super fun. Everybody loves safety. You could read that before bed if you want. And protocol fiction, I think we're in dire need of a sci-fi renaissance in a sense. Most of our literature today is focused on special people. So you have either the super powerful regulators, lawyers, or you have the really powerful tech people, both of whom we tell these stories about um, in our myths about like the extraordinary person who's able to change the world. When in reality, the way that technological development works is these things come onto the scene, they completely change the rules of the game, and they do so for everybody. Everybody is affected by technological change. We need to have stories that express the actual patterns of the world and that aren't fantasy like Lord of the Rings, where somebody has this superpower and they can go on and just change the world for the better for everybody. We all need to contribute. We are all affected by technological change, and we can all now contribute to like better opportunities for what the world will look like. Um, I think with the help of protocol studies. Tensions, of course, we have a limited capacity at SOP to run workshops this year, and tensions, hardened commons, and technical foundations are kind of like the things that we'll dive into. So we've got, corporate workshops and talks that myself and Venkatesh Rao could do. Depending on your field, this would look differently. There's a link there to explore more. And technical foundations. Towards the second half of this year, we're going to go deeper on this and trying to come up with opportunities for people to come together and create a mathematical theory of protocols. And this is the kind of North Star of the program. If in 50 years there's an actual mathematical scientific theory of protocols that people can use to chart social reactions to technology or determine how to evolve a technology like the Ethereum blockchain appropriately, then this program has done its work. If that is done and everybody has like a consensus of how to use protocols in their day-to-day lives. So technical foundations is super interesting. If you're a math head, definitely look into that and stay on the lookout through the newsletter, through this channel for opportunities to go to workshops later this year. I think I'll also mention this quote by Venkatesh Rao. A major component of the work of a protocol whisperer is to manage constantly shifting tensions at an ecosystem level rather than within a single organization. If you work with protocols, you work across boundaries, you are going to have to deal with a lot of conflict, different technologies, different preferences with regards to trade-offs, different understandings of what a good protocol is and a bad protocol. And I think that this field of study can give you the literacy that you need to do that work well. And of course, there are a ton of research questions. This is a young field. If you like to do research for fun, like I know many people do, grab one of these questions and run with it. Get the protocol reader and sit down for a weekend, read it, and then take on a question. If you end up writing something, we can publish it in Protocolized. We can put it on the website. You can give a talk about it. It's all fair game. So thanks everybody for watching. Like I said, this was based on a talk with the Southern California Metropolitan Water District. If you want to do a similar thing, reach out to us with an email. If you need more information, go to summerprotocols.com/workshops. Pro bono, we have limited capacity, but we're really interested in collaborating on this stuff. If you have an interesting idea, join the SOP server if you haven't. There's a link in the chat. And if you want to read more about protocol theory, we have a whole archive, which we will continue to add to. We have the YouTube channel, Protocol Reader, Protocolized Magazine, and you can look forward to actual courses being released open source by our SOP 25 teaching fellows this year.